Red wine, especially when consumed in moderation, has long been associated with potential health benefits, a phenomenon often referred to as the French paradox, the observation that populations with high dietary saturated fat intake, such as in southern France, exhibit relatively low rates of cardiovascular disease. One of the most compelling explanations for this paradox lies in the polyphenolic compounds found in red wine, particularly resveratrol. This plant-derived molecule has garnered intense scientific interest for its ability to activate SIRT1, a sirtuin protein that plays a pivotal role in autophagy, mitochondrial function, and overall cellular longevity. Resveratrol acts as a metabolic signaler, mimicking some of the beneficial effects of caloric restriction by activating pathways associated with energy efficiency, cellular repair, and survival under stress. Central to its action is the activation of SIRT1, sirtuin-1, a NAD-dependent deacetylase that modulates various longevity genes. When SIRT1 is activated, it enhances the expression of autophagy-related genes and improves the function of mitochondria, the cell's powerhouses, by stimulating mitochondrial biogenesis and protecting against oxidative damage. These effects are especially important in aging tissues, where the decline of autophagy and mitochondrial integrity leads to reduced cellular energy, increased inflammation, and impaired metabolic flexibility. SIRT1 promotes autophagy by deacetylating core autophagy proteins such as ATG5, ATG7, and LC3, facilitating the formation of autophagosomes, the cellular structures that envelop damaged organelles and protein aggregates for degradation. It also interacts with FOXO transcription factors and PGC1A, enhancing the expression of genes that drive detoxification, oxidative defense, and mitochondrial renewal. This holistic support for cellular maintenance makes resveratrol an attractive compound for long-term health promotion. Unlike more drastic interventions such as caloric restriction or pharmaceutical drugs, resveratrol offers a food-based strategy for nudging the body toward a state of greater efficiency and self-repair. In practical terms, the richest natural source of resveratrol is the skin of red grapes, which is why red wine, particularly wine made from thicker-skinned grapes like Pinot Noir or Cabernet Sauvignon, contains significant amounts of this polyphenol. When consumed in small quantities, such as a 4 to 5 ounces, 120 to 150 milliliters glass of red wine per day, resveratrol intake can reach levels that exert mild but measurable biological effects. This is not to suggest that more is better. Excess alcohol consumption negates any benefit and introduces significant health risks. However, moderate red wine consumption, especially alongside a polyphenol-rich Mediterranean-style diet, can contribute to a favorable cellular environment that encourages autophagy and slows biological aging. Beyond resveratrol, red wine contains a variety of other polyphenols such as quercetin, catechins, and anthocyanins that further support sirtuin activity, reduce inflammation, and modulate oxidative stress. These compounds work in concert, creating a synergistic effect that amplifies the bioactivity of resveratrol and supports a broader spectrum of cellular processes. For individuals who do not consume alcohol or prefer to avoid it, resveratrol can also be obtained through non-alcoholic sources such as red or purple grapes, grape juice, blueberries, and supplements derived from Japanese knotweed, Polygonum cuspidatum, a plant especially rich in this compound. Interestingly, resveratrol's effects are amplified under conditions of metabolic stress, such as during fasting, exercise, or a ketogenic state, making it an excellent companion to lifestyle strategies that already promote autophagy. When combined with intermittent fasting or nutrient-sensing modulation, resveratrol can enhance the cellular signals that trigger autophagy and mitochondrial renewal. Additionally, since SIRT1 activation is NAD-dependent, combining resveratrol with NAD, precursors like nicotinamide riboside (NR) or nicotinamide mononucleotide (NMN) may further boost its efficacy and extend its effects on energy metabolism and cellular repair. Importantly, SIRT1 not only enhances autophagy, but also helps the cell decide when and how to engage in self-renewal. It promotes survival pathways in conditions of mild stress and works in tandem with other longevity regulators such as AMPK, mTOR, and FOXO proteins. By activating SIRT1 through resveratrol, cells become better equipped to manage stress, delay senescence, and maintain mitochondrial integrity, a trifecta of functions that supports both longevity and health span. In conclusion, red wine polyphenol, chiefly resveratrol, offer a naturally occurring mechanism for activating sirtuin pathways, enhancing autophagy, and preserving mitochondrial health. While moderate red wine consumption can be a pleasant and culturally rich way to incorporate these compounds into the diet, the core benefits stem from the polyphenol themselves, which can be accessed through a variety of plant-based foods and supplements. Resveratrol's activation of SIRT1 creates a cascade of protective and regenerative processes that support cellular vitality, detoxification, and resilience, positioning it as a key ally in the nutritional promotion of long-term health and graceful aging.